Hi, everyone. Welcome. Have I said I would educate someone or everyone. Mostly, though, I learned quite a bit doing these kinds of activities myself. So I think we're all learning. And when I make charts and I redo charts, and I think of that as when I finish a day or a month or some activity, I am never the same person after I am done. When I look back at my own work, I recognize everything I've done needs fixing. So this is the right process, I think. The pandemic of bad charts started with a pandemic. And I remember watching this White House briefing and looking at this chart on the wall and dying inside a little bit. I have, some people get COVID. I get the sense of a horrible hollowness when I see very, very, very bad charts. And I don't mean bad charts because someone didn't have time to do it. Clearly, there's an important event happening on the planet that is continuing to happen. There's a tremendous amount of expertise that can be brought to bear to communicate information. There's a lot of data. There is no reason why we should be looking at something that is not absolutely fantastic. The problem with this chart, and you may have seen aspects of charts like this and a variety early on about mitigating the pandemic, about lowering the number of cases, about stretching the number of cases over time. The problem with this chart, there's four problems. The least problematic is the fact that there's illegible aspects of the chart that are difficult to see, things like textures. In fact, this chart commits this terrible crime where it's both quantitatively inaccurate and qualitatively inaccurate. In other words, the shapes of the curves are absolutely wrong. These are Gaussian distributions. This is a normal distribution. Anybody who made this chart, who would know a little bit about epidemiology, would know that that's just the wrong shape. And the reason why we don't want to give people the wrong shape is because the right shape is not symmetrical and things start much more quickly than they taper off. And so people should be prepared for this. Also, it's quantitatively inaccurate. It gives the wrong impression of how pandemics are mitigated. The size position of that second curve is incompatible with the position of the first curve. Let's look into this. Let's look into these two curves. What winds up happening in kind of a simple models of pandemics is the peak time happens quite quickly, this little red bar, and then the pandemic kind of tapers off as the number of infected people drop quite a bit more slowly. Moreover, when you reduce the contagion of the pandemic, this reproduction number, and you see the curves get shorter, meaning fewer cases, they also move a little bit further in time. In other words, the peak of the pandemic happens later. There is a relationship between the height and the position of the peak. And there, you can't just put the curve anywhere you want. It's a function of this or not. And so let's look at that original graphic. So I looked at it carefully and I discovered that this second peak, what they call these community mitigation, has 42% of the area and 30% of the height of the original peak. And it is, if the original peak is at time 1, it's at time 1.35. So the implication is, if we do our job, we can delay this peak to 1.35 times into the future. Okay, so we buy ourselves some time. And we lower the peak height by 42%, and we have 30%, the height by 30%, and we have 42% of the cases. But if you were to actually model this, the real curve, the thing that would actually happen if we said we're going to keep the height, is that the peak would happen much, much later, twice as late as the original peak, which means that things wouldn't be over when the graphic said it would be over. They would still be actually kind of in the middle of the peak. If we were to match the area, in other words, we would say, okay, we're going to have as many cases as the graphic implied with mitigation, we would be pushing this peak to 3 times or more into the future. And so clearly what this would say is, well, if we do our jobs, the pandemic will last for much, much, much longer, as opposed to what the original graphic implied. And so there's the problem with this graphic, is that it gives you neither the proportions of what to expect, nor the timings of what to expect. It actually does very little to educate. And there was a missed opportunity to tell people how kind of simple models of these things evolve, and then expand to more realistic modeling of what might happen. Now, when you're making a chart, let's say it was you. Yeah, I know you wouldn't make a chart like this. What can you do to make charts a little bit better? Well, you can dispense with textures, for one, and you can use colors intuitively to try to encode good outcomes and bad outcomes. So for example, if there's a bad outcome, you might encode that with magenta or red. Maybe don't use red too much, because red is a really pure RGB color. And I think that a little bit of magenta makes things also easier for colorblind people, because it mixes in a little bit of blue. If you put a little white outline around your peaks or shapes, it can provide a little bit of relief for the eye and emphasize where things overlap. Notice I put a little bit of opacity on this magenta curve so that the blue shows through. These subtle things layer things on the page, and I think allow us to see the proportions entirely for each piece, even though there's overlap. What would that chart, what should have that chart look like? The point of that chart originally was, what is the story in this chart? When you make a chart, we always think, what is the take-home message? The take-home message is, why don't we want big peaks in pandemics? And of course, as you know, because you've seen this chart over and over and over again, but only quite a bit later into the original pandemic in the first wave, is that there's a capacity for the healthcare system. And when we go over this capacity, we have high mortality because people are not taken care of, and we want to avoid that. And this is where I put the magenta in, because this is a bad outcome. So the blue is intervention. That's a good outcome, kind of naturally and intuitively a nice color. And red or magenta is not. It's the color of blood and disease, so we don't want that. If you really wanted to look ahead at that time, what would you have shown? Well, you would have anticipated that there would probably be a fall wave, and then with vaccination, there would be some projections that we would be making about future waves that we would not be certain about. And so giving the public this idea that at any given time, they'll be looking at data of things that have happened, but they will also be looking at projections, and there are many models that we could use, and there's uncertainty in each model, and basically prepare people for a journey down modeling and quantitative discussion of data about a topic that nobody really paid attention to, because the last big global pandemic happened a long time ago. So when you make a chart, one of the things that you can look at are things like encodings and color, but fundamentally, just like when you're speaking, you have to know why you're speaking. What is the goal? And if you can embody the purpose of the chart in the design, then nobody has to ask themselves, why am I looking at this chart? What is this figure trying to tell me? I don't know. This figure is fine. It's a poster figure. It's fine. The little bit of blending and overlap is nice, but I don't know why I'm looking at this figure. Is it the peak? Is it the second peak? Is it the first peak? So what can I do to emphasize the fact that perhaps maybe the second peak is important? I could highlight it like this. I could use color. I try to generally use as little color as possible and save color for emphasis. But suppose it's the area of the second peak that's important. So if you were to draw something like this, I don't have to tell you the area of the second peak is important. The chart tells you this. Moreover, I give you some quality of life improvements to the chart where I show you the proportions of the areas, and I even give you the ratio. And notice how I label the column that gives you the ratio, which is this blue square over the gray square. I don't need to use words here. I can just use a ratio of colors and you know what that means. And those squares are carefully sized so that they're the same height as the bar, so that everything matches up. One of the things that, a lot of things bother me, as you probably can tell in the way that I present charts, but one of the things that bothers me more than other things is when the symbols in the legend are not the same size as the symbols in the chart. It's a minor point, but it's all about consistency, and it's all about reducing the variation in the vocabulary of your symbols to emphasize the variation in the data. This is key. So embody the purpose in your chart. We get these weekly, not anymore, but we used to get these weekly briefings in our province in Canada where a lot of charts were shown, and good job was done in presenting data and updating the public. And we get charts like this, right? And I get it. People are making these charts every week, and there's a stack full of these 30, 40 slides. It's you know, it's pretty granular explanation of what's happening. But I have to think still, even if you're making so many charts in a week, I know you're busy, but it is a public health emergency. So could we do a better job? And these charts smell like default settings in some kind of software, possibly Excel. And the default settings may not be ideal for rapidly communicating complex information. So what's the problem with this chart? Well, a bunch. The text, yes. Do we need all these dates on the bottom axis? No. But what's the story? What's the purpose of this chart? Has this design embodied the purpose? Have you figured out what the purpose is? I mean, the title is really generic, critical care implications of dynamic model. Well, what are the implications? Can you tell me quickly so that I don't have to untangle all these words and mask things out so that I focus on the point? The point of this graphic is this purple line. It's the line, it's the prediction of cases as a function of different amounts of restriction, social restriction. The colors are very strangely sequenced. How could we do a better job? Well, we could simplify things and just throw things out and say, well, on April 20th, restrictions are loosened, and then a bunch of things can happen. If we do not mitigate and return contact level to 100, cases will rise, magenta, bad. If we have current restriction, which is approximately 30% of normal, cases are low, but if we go up to 60% of normal contact level, cases are flat, and that's the point. This outbreak avoided label is the most important label on this graphic because it kind of modifies the legend to tell you which parts are acceptable or good outcomes and exactly why those outcomes are good. What are we avoiding? You could even take the color away and identify this point in this pivot point in the chart where you want the eye to go to right away. That's the purpose. And so how do I make the eye go to that line right away? Well, I could highlight the areas of bad outcomes and the areas of good outcomes with blue and magenta, and then give the answer, which is the maximum tolerable contact level with some uncertainty. And the eye goes right along this black line. It sees 62%, and that's the answer. And the chart actually tells you the answer, roughly. The original chart didn't actually tell you the answer. It gave you a bunch of different levels of contact restriction, but it did not identify the one that was the best, which is a little bit unfortunate. The chart could say that, and then when the person is speaking, because the chart is a prop, you're always the presentation, the chart is just a representation. You don't have to explain the things that the chart could explain on its own. And notice that the title is an active one. So remains acceptable as restrictions are relaxed at 60%. Have very active titles on all your charts. If the chart were to disappear and the title will remain, in many cases, the title should tell you what has disappeared or what the conclusion is. It's a good tip. Do not put in your chart a title that says a scatter plot of. Do not tell me what the encoding is, because I can see what the encoding is. Mind your encodings. Usually it's not about the encodings. Most people get the encodings completely fine. If it's a scatter plot, it's usually a scatter plot. And with the exception of a couple of rogue pie charts out there that I am almost finished eradicating, the encoding is almost never a problem, because for simple charts, people can get around. However, sometimes people make mistakes where the mistake is so strange that you must think, how could this be happening in a media outlet, which is our major public outlet? CBC News in Canada is like the BBC. So they make a lot of charts. And you wonder, how could they have done a mistake that is so weird and pernicious? And it's not even really subtle, but I mean, the chart looks good. It's nicely formatted. There's color. It's not sloppy, but the confidence interval is encoded by a series of 2 bars, and the value, which is the average, is encoded by a bar, which is really strange because you think of the confidence interval as a bar and the average as a position. Moreover, strangely, Canada, which is a country made up of provinces, is in one of the rows, which is very strange because this is basically the average of all the other data. So it doesn't really belong in the middle of the chart like this. What would you have done? Well, you probably would have done what the natural thing, which is draw the confidence intervals as lines. Put the average, Canada national average on the top, and then all the provinces below. And then you would anticipate some questions such as, how does my province compare to the national average? So maybe have a bit of a quality of life improvement where you highlight a region that can be used as a baseline to compare all the other data values against. So for example, here, right away, you see British Columbia and Atlantic region, the averages are lower than the bottom confidence interval of the national average, which is nice. And Alberta, yeah, Alberta is our special case. They're much higher. And these 2 things stand out very quickly, whereas in the original chart, because the confidence interval is a series of bars, this is not obvious. Now, this is parsable. If I ask you the question, which province has an average that is higher than the bottom interval, top interval, bottom interval of the national average, you'd be able to figure out, but it would take time. And then, there's always a couple of things you can tweak, and here just a minor tweak, which is that gray highlight at the national average is just a little bit darker. And so it sets it apart from the rest of the bars. Not necessary, but always think about how you can texture the meaning of each track or each element in your chart. So in this case, right, Canada came first because it's the average. And so I had to reorder things, because usually software and people do not always get the order right. So here's a chart. And this is a sloppy chart, okay? And there's a lot of things with this chart that could be better. But fundamentally, the trick is, what is the order of these things that are changing over time? So here is these strategies like delay the maintenance of consolidation of chemotherapy, etc. And this is what we did in the first wave blue, and what we're going to do, what we think we're going to do in the next 3 months. Okay, so what is the order of these things? I don't know. It comes first, which is the least interesting. Okay, well, no specific changes required comes second. Okay, so far I know nothing really. And then if I look, is it the increase of the blue? No, because the blue is higher than here. Is it the increase of the orange bar? No, because this orange bar is shorter than here. I give up. So I've lost, the chart loses the opportunity to sort things based on some kind of a meaningful pattern, to emphasize this pattern. I have to figure this pattern out myself, and I can't do it. So what would we do? The first thing that we would do is we would just make this chart less sloppy. Keep the order as it is, not fix the order yet, but just make it less sloppy. And maybe put the legend in as part of the chart. The legend was really wordy, but if you can work the legend into the chart, kind of like a data point, then with a small number of words, you can explain why the chart exists, right? Use strategy, next 3 months, first wave, done. The next thing that I would do is comparing things to the first wave. So the first wave should come first as I scan down, and then the next 3 months should come second. So the first wave will be gray baseline. It's really nice to use gray when you want something to compare to. And then blue, because I'm using the blue color here because I'm thinking that we're on the learning curve, so things will be better. We'll be making better use of our strategies. Okay, but the main point of this chart is this side chart that explains the order of which I've reordered of the original chart, which is this change in use. So this is the strategy that will have the most increase in use. This is the strategy that will have the most decrease in use. And so what will we do less of? We will do less of defer routine imaging. We will do imaging right away. We will not wait. And then other gets put at the bottom because it's other, who cares, even though it doesn't really follow the order, but you understand why it doesn't follow the order because it's other and you don't know what other is, so forget about it. In fact, why even have it there? This second chart actually is very necessary for, I think, unpacking the first chart because there's a lot to unpack there. And so if you can provide this, this is almost like a legend, this explanation of why you've ordered things in the chart, why things are shown in a particular way, it's very, very powerful. And I spoke about legends and kind of taking the legend and working it into the chart as a data point. And there's this reflex that a lot of people have is my chart must have a legend. A lot of software automatically creates a legend when there's only 2 points on the plot, category A, category B. Software will make a legend, category A, category B, and really the labels could be next to the symbols. You don't need a legend. There's a lot of charts out there where the legends are a bit like a heart attack. And they're completely unnecessary because they imply that there's something to be received from this legend. Like here, look at this legend. Oh my God, these dates, I can't keep track of them and the colors. Just forget about it. Why is everything a different color? Does it need to be a different color? It's a function of time. The colors change with time, but the colors themselves don't mean anything. And they're kind of weird because it's kind of a desaturated red and there is this very vibrant neon green, then it's this kind of pinkish, and then it goes not great. So, and then why is this text vertical? What could be, how could this chart be fixed? When you're fixing a chart, what you're doing is a couple of things. One, you're making the audience a little bit less cranky. Two, you're learning how to use space efficiently so that when you get to a complex case where there is indeed a lot of data and you have to be very efficient, you're ready. Because in this chart, there isn't a lot more that I could add. There's no space. But if I were to fix it, and the way that, in this case, it was fixed, was that the layers of navigation were thought of separately from the layers of the trend, which is this big, bold, black line, which is the one thing that I basically kept, to the layers of the forecasts. So the forecasts are things that are shown in orange, faded orange. And they're the things that they're shown in the same way because fundamentally it's the same data type. It's a forecast. So we group these together. We see, oh, these must be similar nature in the underlying representation of the data. The text that tells me what has happened, specific events in time, I've decided to put on the top, which is kind of unusual because if you remember, the texts were down here because you always think of the x-axis as being somewhat on the bottom. And so having an x-axis that labels at the top is a little bit unconventional, but there's no reason why that can't happen. And the reason why I put it at the top is because look at this empty space in the chart. Once the eye scans up, down, it hits this trend line. It never goes here because there's nothing there. But if I had all my x-axis labels at the bottom, the eye would have to traverse this desert of nothing to look at the labels, and it's unnecessary eye movement. Now, you might think, yeah, but that's not such a big deal. I do it without even thinking. You're absolutely right. For one chart, it is not such a big deal. But when you're thinking about giving a talk to people, and maybe these people are sitting in a conference, and maybe they have to watch 20 talks, and they have to look at 1,000 slides, every little bit of help that you give them and being able to take things in quickly makes your audience less tired. So they don't walk out on the last talk because their eyes are too tired, and they stay and they pay attention. No matter how simple something is, it can always be made probably simpler and better and clearer. And all of these little tweaks speak to the narrative and the meaning of the information. So I was thinking of this chart, which is really great. The Economist has excellent charts, especially when it comes to laying out text. Notice how this chart could be a heart attack, but it's not. It identifies 5 traces that are important. It uses colors reasonably effectively, and it puts the text in a way where it's legible. So some text is inside the chart, some text is kind of outside. The grid line is broken to read the text. The length of this callout line kind of varies. This is really nicely laid out. Look at good charts and just copy them. Just copy the colors, copy the format. You will learn quite a lot. I've learned a lot doing this kind of, taking this kind of approach. This will save you from having to make charts like this, where you have these forecasts and there's all these different models, and they all basically show the same thing. So why not show something like this, where you have an ensemble and individual models, and get an idea that they're basically all agree, except maybe this one is a little bit weird. So for example, this model is different than others slightly. And so now the goal is to find the color of this model over here. Is it GA Tech or is it UCLA? I don't know. Am I sure? Yeah, I don't know. In fact, these colors look the same to me. So what you might want to do is anticipate a question of, might somebody ask what this model is? If so, label it on the graphic. More charts like that. This is actually quite pretty, but it's not particularly communicative, other than a bunch of models agree, and some models agree slightly less than others, but they all fall within this range. Yeah, so in fact, color is not necessary here. Again, most of the time when you see color in a chart, you can assume that it's not necessary, and then you have to find a reason why you should add color, as opposed to assume it's necessary and find reason why to make it black and white. These kinds of charts with predictions are very strange. Sometimes they're frustratingly strange, such as this chart where there is an arrow to current, which says 0, but this is above 0. This is like at 3 or 4. So I don't understand what is being shown here. Why is it slightly different colors of blue? And these colors of blue in the legend, which colors do they correspond to here? I don't know. So do I need color? Do I need the text? Is the impact associated with this line? Notice how really the chart is about these 3 prediction lines. It's not about the area, it's about the lines. And by coloring the area, you've made the chart be about something other than what it is. And it'd be a lot easier to just have 3 lines, as we've seen in other charts, to emphasize the fact that these are 3 different models. The model is a line. The model is not a motley of different colored areas. Maybe you're thinking, I have a chart to make this week, this month. Maybe I need to make a poster, and I don't know where to start. And somebody told me that I shouldn't use a table because tables are boring. Well, that's not true. Tables provide us with the foundational structure for organizing things on the page. They put things in row, they put things in column, and a lot of times that's what you want. And you want to borrow from a table this sense of organization, and perhaps in each cell put in a little bit of graphic. So here's the CBC again, yay, boo, because their tables are terrible table. Table is like not sloppy, but it's redundant. There's a lot of words that repeat years, but there's some subtle weird things that don't age well. So for example, we have a no vax column. Okay, not vaccinated. We have a one dose column. Okay, and then we have a full vax column. What do you mean by full? Is full 2 doses? Is it 3? At some point we thought full vax was 1 dose. Then we thought it was 2. Now do we think is it 3? So it would be better to say how many doses the person has received, so that when somebody looks at this chart 3 years later for historical reasons, such as now, they will know exactly what full vax means. Notice it's not explained anywhere. Also, what winds up happening is when you decide to draw bars with and provide values next to the bar, which is a good idea, sometimes you get into this case where you can't put the number at the end, so you got to put it in the middle of the bar, you got to change the color of the number, and now you've got a number, which is a layer of information, changing formatting, which actually breaks up how we see the number as a single group. What do they also do? They show deaths, they show admissions, and they switch colors because deaths, black death. Yes, but no, we really don't need this change in color. And then finally, I only show this because I thought it was kind of arcanely curious that they would use an infinity sign for a ratio where the denominator was 0, which isn't really what happens. That's not how infinity works. And so to the public, we're showing an infinite ratio, and nobody knows how to interpret this. Nobody can explain to you what infinity is, and they certainly cannot just look at that and go, oh, I know what this is, and I know how to interpret it. And so there's a little note that tells you what happens, why it's infinite, because there was really fully vaccinated people in the ranges. Yeah, that kind of unpacks it, but not really. So a couple of things to think about. One, everything matters, right? If you're a nihilist, nothing matters, and you're the opposite of a nihilist, everything matters. And I think everything should always matter. So for example, if you were to use an N dash, which you should for ranges, which is a slightly longer dash, and you were to type this stuff in and then center align the text, you notice that because the digits are all different width in a proportionally spaced font, the N dashes are all slightly differently positioned, which is a little frustrating to the eye. So what I do instead is have 3 columns. One column is this number. The N dash gets its own column, which is aligned, and then the upper end of the range gets its own column, so which is left aligned. And this means that the N dashes are perfectly aligned, which looks better. You probably didn't notice it, but that's the point, is all this little minute variation should not be because of labels or navigation elements. It should be because of data. So what I would do for a table like that is remove all the lines and instead use space to organize things on the page. Put the number rate per 100K on the left, put the fold change on the right instead of inside. I prefer it this way because then I don't have to play this game of does the number fit in the bar. I can pile in quite a lot of individual tables in one table where I have hospitalization, ICU, and death. In each column, I have 1 dose, 2 doses. And then the comparison to the unvaccinated is provided by the ratio. So I mentioned this idea of anticipating questions and answering them. So here's a CBC chart, and we have how different countries have handled the second wave. How? I don't know. How? Tell me. Where is the second wave in this chart? I don't know. Is it in the first peak or the second peak? and tell me how they've handled it. I have to do all this comparison myself. So what would I do is highlight the area of the wave that's relevant, whichever peak it was, decide to pick a reference country, let's say Canada, that gets the yellow highlight, and then put the height of the peak and the width for each country at its coordinate position. And this allows me to quickly compare things, let's say to Canada, because that's the implication is, are we doing better than others? To make this even faster, maybe redo the graphic where you don't show the raw data, although showing the raw data is actually really great. And a lot of times I think these two go side by side. For the quick explanation, placing the positions of the peaks in their own plot. So here's Canada, the long grind, here's Spain, slow recovery, etc. You can put little annotations that give you a headline for the story to help people remember what is happening in individual countries. And all of this little annotation, time of second peak, second wave, etc., find ways to fit that in. And notice here's the orange value of 7-day average right next to the grid, and the orange picks up the color of the bar because the orange is the data, everything else is annotation. Gestalt. And there's a couple of guidelines when I'm making visualizations, but none more important than this idea of how we organize things when we look at them. So, okay, don't be the important person. This slide does speak for itself. Space is very important in the way that it creates groups. And you want to take advantage of this. This is why you often don't need cell boundaries in tables, because space does a good job for you, and color tries to make up for this, but often if the space is too great, it cannot. So colors makes groups and space makes groups. Do not group things that are not related. So for example here, can we help people quickly assess, for example, the second wave stringency index? Not really in this chart, because it's red on gray, which is the same as the red on gray of the first wave. So things don't group as well. If I change the colors of the second wave and the first wave, yellow and gray, and I highlight the stringency for the second and first wave differently, I can now say, look at all the red traces, look at all the orange traces. And your eye can very quickly look at the red without being distracted by the orange or the blue. That's how Gestalt grouping works. And just to make sure that people who are colorblind can see this, I would, check my colorblind emulator and look at the chart and say, well, does this break completely? In this case, these two colors look similar, and then I have to say, well, do I need to change them, or can someone still make up for the meaning? One of the things that is tricky when you're talking about certain subject matters is that the natural scale of things is a little bit inconvenient. So particularly genomes. Here's a New York Times graphic of the mutations in Omicron. This was widely criticized as, why are the mutations not shown in red and everything else is shown in red? It's generally, it's a beautiful graphic because it gives you the three-dimensional shape of protein, but the color is not great. So here the scale is, well, the choice to go to 3 dimensions does impart a little bit of new information, but the color isn't great. If you want to look at mutations in the variants, they pile up quite densely in certain areas, and then there's a lot of areas where there's no mutation, and that's because you're showing things to the natural scale of the amino acids. Here, for example, you're looking at the genomic scale, and look at the spike protein area and look at all these mutations they pile up, and you can't really make them out. And there's all this uninteresting part of the graphic, which uses up space and serves no purpose other than to say there's nothing here. So I thought about this, and I decided to make a little comparison of how one might present the positions of mutations in different variants. So what you're seeing here is you're saying the same graphic at the top reimagined at the bottom with a slightly different scale. So each row in the graphic represents a variance, alpha, beta, gamma, and so on. And then you have the genomic scale, and it's colored by the different ORFs, so the different parts of the genome that code for protein. And this is to scale. So what you're seeing is you're seeing the positions of mutations that are found in at least a certain fraction of each variant. And you see that in the spike protein, there's a lot of mutations and they pile up, and it's kind of hard to see what patterns there might be because there's a lot of empty space in the graphic. So what I've done below is I have counted the number of mutations in each colored area in each ORF, and I've rescaled the ORF in proportion to the number of mutations. So what does this do? This does break the scale factor, and it suggests perhaps that the spike protein is much larger than, let's say, ORF1A, which it is not. Spike protein genome section is quite short. However, it's very dense with mutation. And so the question is, what's more important, showing the patterns of mutation, possibly stretching the scale, or showing the size of the region? The size of the region, I would think, genomically is less important than the space of mutation profiles. If you think of it this way, the spike protein is larger in terms of the variability in where mutations happen and how many mutations there are. And what you're also seeing here is that each mutation is not treated the same. Is it unique to a variant? Is it in 2 variants? Is it in 3 to 12 variants? Or importantly, is it in all variants, right? Because there's the original Wuhan strain, and then there's variants of concern and interest. And so, for example, this mutation here is in all the variants, so perhaps it's less interesting than the ones that pile up in specific variants. And the tables off to the side, like this, let's go here. What they do is they take that graphic and they take out all the variants, all the variations, the mutations that are unique to a variant, and they basically tabulate them. So you can quickly see at a glance where the mutations are for each variant, in what region. And so, for example, the story of the Omicron, spike protein mutations, this is where things really happen. And look how many mutations there are in Omicron, and this is why this variant caused quite a lot of concern when it was first sequence. So finally, what I want to talk about very briefly before we go to questions is this idea of playing around with data, practicing a lot, making some art, and exploring without necessarily a purpose or the kind of formal grounding that you might need when you make charts for things like papers. So a long time ago, I thought, what does a genome look like? How can I represent a genome compactly and artistically? And I decided to draw things as a path. And the path was a function of repeat content and other things as well. And I made a graphic of genomes called the deadly genomes, of genomes that harm us or genomes of disease. So either viruses or bacteria. And I kind of resuscitated this with COVID and started drawing these COVID graphics where taking the genome and drawing as a path. This is essentially data art. This doesn't tell you that much about the genome itself, other than perhaps where the repeats are, but you could draw the variants and you can give people the sense that the genomes are changing due to the positions of mutations as you accumulate them across variants. And what you could do is you could color the path based on those ORFs that I showed in the previous graphic and show the positions of mutations. And then you could take all of those pieces, break them up, kind of reorient them and show them as a table to kind of show the anatomy of SARS. Now this is kind of quite sketchy in terms of demonstrating what are the changes in the genome you don't know, but it's fun to look at and you can start the conversation. The genome is made up of different sections. These sections vary depending on the variant because of mutations. This is actually the length of the section and so on. And it gives people a way to enter into the understanding of the graphic and without being overwhelmed by too much technical detail. And then you can expand on the technical detail, and the graphic is always there to kind of fall back on when you need a rest. You can organize the variants kind of in a more like a landmass shape. I spent probably 3 hours trying to figure out where to place them. This was all, manually rotated and placed just so that they're kind of almost touching. The label placement here was very frustrating. Where do I put the label so that it's unambiguously associated with the variant, but the whole thing kind of looks like one structure? It's a lot of fun to play with. Should generally take the time at the end of creating a figure, or really anything you make, be it words or drawings, to just kind of give it that few moments of polish, and this can take quite a bit of time as you subtly adjust things and go, we comb it over, and you comb it over quite a lot. Even the text can take a long time to write. And then finally, I want to finish with this idea of sometimes data visualization is about expressing our confusion about the subject matter. So here are a large number of variants drawn as paths. And instead of putting them in a table, I thought, why don't we just take them and align them together right on top of each other to give you this ball of genomes, which the implication is we are meant to untangle this and reach a better understanding of these data. And so in a way that's what the ball says. It's messy and it's nasty, and we have to keep working better to figure it out. So thanks so much for your attention, and I'm very happy to take any questions about anything you've seen or you'd like to ask me. Thank you.